Okay, so welcome to the Bendigo Tech School's live streaming live streaming week, I guess. I'm just changing a couple of things on YouTube. Sorry, I'm changing us from entertainment to education, though I'd like to think that we are entertainment as well. Okay, so I'll click that across, and okay, so welcome to the Bendigo Tech here. So I'm not hearing myself, and I'm going to drop that down. Excellent. All right, so let me turn off that window so you can see me. I'll turn on my capture. Hello. So welcome to the Bendigo Tech School, as I said. Today's live session is on laser cutting. Now, I'll give the same little notes I give at the start of every one of these sessions. Actually, I'll switch to my big head. There we go. I'll give you the same notes that we do at the start of every session just because we have a few people come on that haven't done a live streaming session with us before over YouTube. So obviously I'm in my office and we have some equipment coming in. So this will be sound a lot better anyway. I can't say I will look any better, but I'll sound a lot better soon enough. So on YouTube live streaming, there is about a 20-second delay between what I'm doing and what you're seeing and what you're hearing. So just bear that in mind. There is chat on the side there, so please feel free to use chat if you have any questions. Put them in chat, and then 20-30 seconds later, I'll probably get to them so I can see what we're doing. And that's about it. I'll press the record button in a second. I'll record this because at the moment, the quality on YouTube can vary depending on their limits with bandwidth at the moment, where lots of things are limiting their bandwidth. So I'm going to record this as a high-res session too, so you can watch it back a little bit later. But we'll probably be talking more in this session because we're kind of talking about laser cutting in general and talking about the techniques to make something. So this is based upon a PD we would have run in the tech school where you would have come in, we would have given you some skills on laser cutting, had a look at our laser cutter. We use a Trotec Speedy. There are many laser cutters. We can talk about those as well. And then we would give you the skills to actually create something and create, I think they're making like a piece of jewellery or maybe a business card, something like that. We can still do all of that minus the making because we're not in the tech school. But what we can do and what we're encouraging teachers to do is to go through this process and make something, have it ready to go, and you could always email it to us and we can produce it for you. We can cut it out and we can send it your way. Heck, I could even do it at home in my garage. So that's the plan for today's session. So what I'm going to do is I'm going to hit record in a second, and then we'll talk about the laser cutting. So let me just do that. I'm going to go down here. Excellent. All right. So I'll hit record. Now, obviously, in terms of laser cutting, those of you that know me, it's probably one of the things that I like the most. I would give a plug for my little side business, but I won't because I shouldn't. That's not right. But in terms of laser cutting, I have a bunch of stuff that I've been making myself. And I'll use that as, I guess, examples of some things that you can do. I'll try and pick some of this stuff up. So this is something I just made recently. It's going to be interesting to do with my webcam. I might even tilt that down. This is something I've just made recently for RAF to play with. Essentially, it's a wooden tool set, okay? And so we've got these tools here that you can kind of, they're quite tiny, but that's the point. And there's a little board that they kind of go on. So this was for him because he loves the little tools. When I start working on the tools, he loves having a go, but I didn't really like those plastic tools, so we designed our own, and you can see they've been put together. So pretty simple stuff. Now, I guess the main thing with laser cutting is a subtractive manufacturing process, okay? And by that I mean we're taking stuff away to make what we want. So let me just say, I've got a limit on my headphones. Hold on a second. All right, here's something else that we made for Raph the other day because he's into bluey, right? So what we have here is I've got a bit of plywood. We use plywood a lot in the tech school with laser cutting, but you can cut acrylics, you can cut metal depending on the power of the laser. So this is subtractive. So we have this. I did have a piece of ply here, obviously a normal piece of ply, and then I've kind of cut in my design. I've cut these pieces out, and so what I've got here is a puzzle, okay? And I've made that by taking pieces out. Please don't sue me, ABC Kids. Obviously, I don't have the rights to Bluey, but no one makes handmade Australian Bluey toys, so I did. Anyway, so yeah, that's what we're doing here. So you can see I've just got my plywood, it's cut through, and I've layered that together. So it's still quite flat, but you don't have to make flat packs. I like flat pack design, I kind of like having that. But of course, you can then construct something that will go together, that will slot together as well. So like I said, laser cutting, subtractive manufacturing, you've got a material, you're taking stuff away from that material, and what you're left with is your product, okay? let's get started. So to do that, I guess you have a laser cutter. That's probably the main tool. So I'm going to switch off my giant head here, and I'll just go back here. And I might just bring up the slides that we use for our students. I think that will be helpful in showing how this works. So let me just jump down here, and I'm trying to find my slides. Give us a sec. All right, I might just put them across here. I'm just going to bring up the program that we run with students. It's a one-day tech taster program, so we only do it over the course of a day. But in that one day, they do quite a lot. So I'm going to bring that up and just show you what that is about. And you can just see how easy this kind of thing is. So let me just bring that down here. All right, so you just saw my messy desktop for a second then. Excellent. So we might just jump across here, and I'll go into present mode so you can actually see these slides. So there's our laser cutter. There's a photo of it there. It's a fairly large laser cutter. I think it might be 600 by 400, but don't quote me on that. Obviously, different laser cutters, you can get different size laser cutters. What I'm going to do, I'm just going to actually pause the live stream. I don't need to see me. And it'll probably just help a little bit with my bandwidth. All right, so I'm just going to close that down. And remember to use chat as well to ask me questions. So yes, our laser cutter is a Trotec laser cutter. Again, there are many laser cutters out there. I'm going to gear this towards schools, especially in the next couple of days. So this is a brief overview of laser cutting in general and how it works. But over the next couple of days, I'm doing a session on LightBurn, which is a great piece of software which I recommend all schools should be using for their laser cutters. It takes a lot of the hassle out of running a laser cutter, but also creating as well. So I'm going to do a dedicated session on that in a couple of days, and I'll plug that a little bit later because that's probably going to give you the best info that you need on how to actually create something with your laser cutter. And also Adobe Illustrator is another bit of software that we use. So both those pieces of software are vector-based programs. So you need to use vectors to create. And again, I'll explain all this as we go today. So yeah, this is kind of the program we work with the students. We talk about the laser cutter. We're working with Australian Turntable Company on this one-day program. So that they designed and you've probably seen it if you've been into the text of the giant turntable we have here. They've built that, and we're kind of using them as our industry partner when we talk about this. So I'm just going to go through these slides a little bit quickly, and then I'll kind of explain what we do. Obviously, we don't need to talk about turntables today. We don't need to do that. We don't need to do that. Design thinking, we've talked about that quite a lot. I'll be doing a session on design thinking a little bit later, so I'm not going to go over that. I'm not actually, in fact, I'll skip a lot of these because I just want to jump straight to the meat of this down here. So a couple of things. I won't play these videos, but I'll put them in the chat maybe so you can watch them a little bit later. So lasers, I guess, are the main thing. We talk to students about how lasers work because that's what we're cutting basically. That's what we're cutting with. We've got a laser, so we're harnessing power and heat, and we're creating a beam that's strong enough to cut through material. And like I said, how much material you can cut through is dependent on your laser and the power of that laser. So the laser at the tech school that we've got is very fast, and it can cut through. I reckon I can cut through probably around maybe a 6 mil, maybe 7 mil, probably even pushing 8 mil plywood. You can cut through pine, a lot thicker pine, probably pushing pine upwards to 12 mil. Acrylic, anywhere from maybe 1 to 6 mil in our acrylic. I haven't tested it much more than that. And of course, you can engrave as well. You can engrave on most materials. So you can engrave on the wood, the acrylic. You can engrave on much thicker pieces, but you just can't cut through because of that power. You can engrave on metal as well. Laser cutters that engrave on metal, again, depending on the power, a lot of them will use like a spray adhesive that you spray on the metal, and it uses that to actually kind of create the mark. The schools that have laser cutters, I know BSE's got a laser cutter, and a few of you do as well. Generally, they'll still be commercial quality laser cutters. They're probably normally like the Chinese model laser cutters. Now, that's the one I have as well. Mine's made in China too. So I find them to be a lot bigger and a lot more powerful than something like a Trotec, but it does require more of the user to understand and to operate, which is why I'm going to spend a bit of time talking about those a little bit later. And of course, I can help you out on a school by school basis if you want some help getting your laser cutter up and running, because I've been doing it for a while now. So the reason we have this talk of lasers here is I think it's really important that students understand how a machine works, right? Like understand how the machine is actually cutting. How does a laser work? So I'm not going to educate you with that right now, but feel free to I'll look at the links when I'm done here and have a look at how lasers work, how they're using photons and light and all those fun things to create a beam that's powerful enough to cut through something. So we talk about that with the students so they can have an understanding of how it works. Because it does sound very dangerous, right? We're using a laser to cut through things, but it is very controlled, which is good. Then we'll have a look at Illustrator. Okay, so the reason why I have Illustrator here, and like I said, I'll talk about LightBurn later in the week. Illustrator is a vector design program. And so the easiest way to explain how a laser cutter works is, let me just go back to this picture here. So you can see here, here's our laser cutter. And what we have here is we have this main beam, which is going to move left and right and up and down. Okay, and of course it can go the depth Z. So X, Y, and Z, this thing can move. And there's our laser head there. Okay, and the beam is actually a bunch of mirrors. So the laser is in the back here. All right, it fires a beam that hits a mirror here, hits a mirror here, hits that mirror, hits a mirror there, and then goes down. Okay, so it creates a path. So the laser itself is not here. It's this big thing in the back, which you can't see down there. Most schools will have what's called a CO2 laser. It's a big glass one that requires a bit of cooling. So you'll probably have a little cooling system to keep that laser nice and cool as it goes. And that's one I have as well. It's got a cooling system. Then you have your bed down here. Okay, so your cutting bed, which goes up and down. So depending on the thickness of the material, you want to have that at a certain height so it's focused. So you have to actually focus the laser to get the most out of it. Okay, that'll come up and down. So then in there as well, you'll see with ours, we have these little slots there. So that is essentially a vacuum. So what's happening with this is obviously you're cutting materials, there are fumes coming out. Ours is inside, so it's even more important. We have a vacuum pump which sucks those fumes out, gets filtered through, and then goes back out, not into the air in the tech school, obviously, but gets filtered out somewhere else. So that's really important too, that you have a good filtration system for your laser cutter, depending on what you're cutting, right? So if you're cutting acrylics, that's plastic. You want to make sure you've got a good extraction system, so you're not having those fumes in your school. That's super, super important. And also something I would check. Again, I've seen a few laser cutters in schools, especially when teachers, I think, inherit them. Maybe there was a design tech teacher that was using it and they've left and another teacher comes in. I would definitely check your laser cutter check the filters, check the extraction system, make sure everything's clean, because they will clog up, after... I know with mine, after using it for a month or two, I've got to go in and clean all the extraction systems so they still extract really well, or they get a bit clogged up. That is about it, I guess, in terms of the hardware. And that's obviously where you put your materials, okay? And that door comes down, and it's quite safe. I know with the Trotec, you open that door, everything shuts down, okay? But with probably the laser cutters that most schools have, there is more control you have. You can do a lot more with them, like I said, but you really do need to know what you're doing. So what I was getting at with the vector side of things is this laser head here, the red part, basically that's going to move, left and right, up and down this way, okay? Once you've got your material at a set height, you'll generally leave it there. You can adjust it on the fly. So let's just say you're trying to cut something that's really, really thick. You can do it so it cuts one pass, and then that bed will lower a little bit or raise a little bit and cut again. So you can control that. But generally, it's moving up and down and left and right. And what it's doing is it's following a path. Okay, and that path is your design. And so what we want to do is we want to use vector-based software, because vector-based software works on points in space. So it's using coordinates. It's using a lot of maths. And so the laser head is following those points. And I'll show you in a second how it's going to work. It's going to follow those points around, and it's going to cut out or engrave your design. Okay, so the reason why we use Adobe Illustrator is because that's a vector-based program. So really, really important. You can't, put in a JPEG and get your laser cutter to cut it out. I mean, you can do a degree, you can do some editing in a vector-based program to turn it into a vector, and LightBurn actually does that for you. It converts JPEGs into vector cutting systems, which work really well. But generally, you're creating your work. Okay, so that's kind of what we're looking at there. I'll just scroll back down here to our slides. So you can see here's some stuff that we've cut out of nice, simple cardboard, all right? And that's kind of some of the stuff that students are going to use. In this program, in this one here, the tech taster, what we get the students to do is actually design a platform. So to begin with, they build it out of cardboard. I'm going to sneeze in a second, so I'm going to bless myself now. They cut it out of cardboard. But then they actually get into Illustrator. We'll show them how they use it, and they design a platform which can hold weight, because we're talking about the Australian Turntable Company and the amount of weight that those turntables have to hold. And they will design some kind of platform. They will then design that in Illustrator, get the laser cutter to cut the pieces out, slot them together. Because like I said at the start, you don't have to make flat things. You can do these slots and tabs to make things work. And then that will be their platform. That's what they're going to be trying to support. Okay, so they're designing all this from scratch. So that's what we do in the tech school in one day. Okay, so in one day, students have come in. They've never seen a laser cutter before. They're going to learn how to use a laser cutter. They're going to learn how to use Illustrator to control the laser cutter. They're then going to create a prototype. They're going to test it out and see how they go. And the reason why I like laser cutting so much is it's so fast and it's so accurate. I did a session yesterday, a live session. Go back and check it out. There's a plug on 3D printing. And 3D printing, I think, is almost the opposite. Okay, you can create something, but it takes so much time. Okay, and I still find that 3D printing is not accurate, right? Like there's always issues. You've got to go back and change your print. But with laser cutting, if you design something, and the laser will cut it out exactly as you have your design. Okay, which is very, very cool. So that's what we're looking at today. Okay, so that's kind of the fundamentals of laser cutting and how they work. Again, I'm going to now show us how we design for a laser cutter. All right, I'm going to use Illustrator, but I'm not going to go in depth into Illustrator too much because that's not the point of today. That'll be another session where I focus just on Illustrator. So today I'm just going to go through a vector-based program, and I'll use Illustrator as an example, and I'll concentrate on LightBurn in the next day or two, where I'm just going to show you how it works and what you need to think about. And then in those Illustrator and LightBurn sessions, I'll tell you the details on how I'm making things, what strokes are, what Pathfinder is, all this kind of stuff. So don't stress about that now. Today's session is not using Illustrator or using LightBurn. Today's session is going, this is how a laser cutter works, and these are the things I need to do to make it work for a laser cutter. Okay, so that's enough of that. I'm just going to jump up on my top screen here, and I'm just going to open up Illustrator, and I'll bring that down in my bottom screen in a second. All right, so let's see, where are we at? Okay, let's start to make a design. Okay, so your laser cutter is your machine. Think of it like your printer, all right, because it is a printer. It's a laser printer, okay? Price-wise, laser cutters can vary. You know, you can make a laser cutter, like K40s, these really popular kind of hobby laser cutters. You can make a laser cutter for $1,000, okay, and it'll do the job. Or you can buy, like I said, you can buy some bigger laser cutters for anywhere from $3,000 to $4,000 to $10,000, okay, for your laser cutting machine. That's kind of the ballpark figure, I think. Again, most of the schools I've seen have probably about a $10,000 laser cutter, which is more than it's more than enough. It's more than enough that schools need, I think. Obviously the tech school has a Trotec. It's a top of the line laser cutter. I think Graham likes to say it's either the Ferrari of laser cutters, or maybe it's the Rolls Royce. Probably the Rolls Royce. But it is a top of the line laser cutter. It's really designed for mass production, for doing lots of things for commercial projects. So you don't need to get a machine like that. Although I love it, I think it's great. It's super fast. But for schools where you're kind of doing these one-off designs that students are making, I would just stick with kind of like a standard kind of laser cutter. And I won't, give you ideas of products here, but if you do want to have some help with potential laser cutter purchasing, let me know, and I can help you out and kind of help you in those kind of choices as well. So yeah, that's what we're looking at for a laser cutting machine. Let's bring this up here. All right, so I'm just going to go File and okay. And the other thing I like to say to the kids now, I've got this set up 600 by 400. That's the width of my laser cutter. Actually, it's a little bit bigger. It's 700 by 500, but I like to fit the space, so I'm just going to hit create. What was I saying? Yeah, the other thing I like to talk about with students with laser cutters is, yes, $10,000 does sound expensive for a laser cutter, right? But if we go back to the 70s, to buy a laser printer, you're looking at like $10,000, right? So I guess what I'm getting at is the prices of these things will come down to the point where they'll be small and cheap and affordable, and people can just have a laser cutter in their house. So if they need to make something, they can just design it, print it, and cut it out. Again, like I said, I haven't bought a toy for Ralph in the longest of times because we just design them ourselves and we make them. I'm just having a look around because I'm in his little office at the moment. They're everywhere. All we have here is little Rafferty laser cut products. Anyway, okay. So what you need to do now is you need to kind of design your product that you're going to get your laser to cut. Okay. Now to do that, the laser cutter is flat, as we said. Okay. So it's cutting something on X and Y. It's a flat cutting process. So everything you get out of that laser cutter is going to be flat. Okay, they're going to be flat pieces. You can also, you can make them bend, you can make them rotate, you can do all those kind of things with the way you do some cuts. Like there's some really cool kind of wave cuts you can do, so you can actually get the wood and bend it around and make like a round cylinder, which is kind of cool. But everything is flat, so your design needs to be flat as well. Okay, so you need to think about that when you're starting to create stuff. Your design is going to be flat packed. Okay, and then you're going to get all those pieces, and however you construct them is up to you. Are they going to be slotted together? Are they going to be glued? Whatever. Okay, so that's what you need to think about. The other thing you need to think about with the laser cutter is what you want to have cut and what you want to have engraved, because they are different techniques. Okay, so cutting essentially will cut right through your material. So again, I've just got a bit of just playing around with the material. I might just change my screen so I can actually see my my camera. I'm going to move this up the top here so I can see what I'm doing. Okay. So this here is a little bit of laser cut wood. It's a very, very tiny piece. And you can see how thick it is there. It's not very thick at all. So we have an engrave on the front. And we have that cut there. I might even grab something a little bit bigger so we can... Alright, so this is actually a little bit thicker. So this is 7mm plywood. Okay. So you can see I've got that engraving on the front there. All right. And then you can see where it's been cut. It's got this kind of nice... it's not charcoal. It's almost like a caramel, okay, and that's depending on the laser. When the laser cuts, it cuts it so cleanly that you don't get charcoal depending on the material. So we have an engrave in the front. We have a 6 to 7mm cut there. So you can see even with the engrave, if I can get that close enough to the camera, okay, even with the engrave, you can see what the engraving is doing. It's actually burning off material. Okay, oh, that's a dirty finger now from playing with all the plywood there. So it's actually burning off that material. All right. So the more powerful your engrave is, the deeper it's going to engrave into the wood. Okay, so this is a light engrave, so I've still got that nice kind of soft part of the wood there. But if I engrave that, if you have a look there, if I engrave that a bit deeper, okay, you would actually see that to be a lot browner as it goes through. Or if I put more power on it, I could actually burn that a bit more and get a nice kind of burnt look to it. It all depends on what you want. Okay, and you need to set that in the laser itself. So when I show you LightBurn and those kind of things a little bit later on in the week, you'll see how you set the power levels and those kind of things to actually cut your wood here. So engraving through there, cutting through there. Now engraving is a lot slower than cutting. Okay, so when you want to cut something, you pretty much set the laser power to as full as you need to cut through the material. So we have a bit of a material library where we have all of the different pieces of wood that we might use, and there's hundreds of different types of wood, plastics, those kind of things. And I know the amount of power from trial and error. I know the amount of power I need to set my laser to cut through that material. If you don't set it to enough power, it won't cut all the way through it. If you set it to too much, it'll cut all the way through it, which is okay, but you're using quite a lot of power that you don't need, and you can burn the wood a little bit. So you do need to figure out the exact kind of tolerances and stuff for cutting. So I know the exact speed and power I need to cut through this material. And once you set that, it'll cut through it quite quickly. With engraving though, it needs to kind of think of engraving like a laser printer. It's going to go back and forth, back and forth, back and forth, back and forth, back and forth. Okay, it starts from the bottom and works its way up. So every bit of engraving, it has to get passed over by the laser. So it does take a long time because the laser has to run. If I kind of move back a bit, the laser's running going, and it's just burning those little bits there. So to cut this, I think you'll be looking at on a Trotec probably about maybe 4 or 5 seconds. And to engrave this, we'd probably be looking at about maybe a minute. Okay, so that's quite a big difference in time. So you want to kind of think about that as well. Do you need engraving on what you're making, or is it going to be cutting? I've kind of gone down to doing a lot more cutting than engraving, just for time. So again, if we go back to my little my tool set I made for wrap, okay, so these are all just cut. They're not engraved because I've just used multiple cut pieces and I've kind of glued those together to give that look of a 3D kind of paintbrush. Okay, so you can get clever in the way you do things and change the way you do things to get like a different feel to it. And I've given that a bit of an oil, which is why it has that look, which is kind of cool. So that's your options there. So engraving and cutting, that's what a laser cutter will do. Depending on the material is the amount of power you need to do either of those two things. Okay, so how does that work now? You can make this dinosaur, I suppose. So let's just make a circle. So again, don't stress about what I'm doing and how I'm doing it here in Illustrator. We'll spend time later in the week and we'll look at that. Okay, so I'm just going to make a circle. And I'm just going to increase... Actually, what I'm going to do is, I'll increase my screen just so it's a bit easier for you to see for the live stream. And on the recorded video, it should be better anyway. Okay, we'll do that for now. All right, so I'm just going to go in here and I'm just going to increase that. Okay, so now you can see I've got a circle here. Okay, and it's like I'm just going to make it a hollow circle. Okay, and I've got a black line. And what I'm going to do for the sake of our demonstration today is I'm going to make that red. Okay, so I've got a red line. Okay, so that is going to be my cut line. Okay, now this is a vector, so let me explain a vector really quickly. So if we have a look here, I'm going to zoom in. We can see my circle is actually only made up of these 4 points. Okay, and because it's a circle, it actually also has these control handles, which if I tilt, I can control the movement, okay, of each of those. Now, every single one of these vectors has a point in space. So if I have a look here, if I go to this one here, you can see where it's at in the X and Y axis of my document. They're all different. Okay, and then these control handles will also have their own information as well. So it's saying, well, that point is there, but it's going to angle off at a certain ratio, which is handle controls. Okay, so they're all numbers. It's all maps. Okay, even if I did a square, actually, a square is probably even an easier way to give this an example. If I do a square, we have a square that has 4 points. 1, 2, 3, 4, and each of those at a different point. Okay, so this square is actually only made up of 4 points. This circle is also only made up of 4 points or 4 vectors. Now that means if I want to enlarge this square, or I want to enlarge this circle, I can do that. Okay, and they are both the exact same quality that they were when it started, except those points are now in different spots. So what's happening is the software is doing it on the fly. It's redrawing that circle. It's recalculating these points and the distance between them and redrawing the line. My computer is fast. All our computers are fast these days. Go back 10, 15 years, the computer would have to calculate that and then redraw the line, and it'd take a bit of time. But now it's really, really quick. So that's a vector. That's those points, and it creates that shape. Now, the reason why this is important for our laser cutter is because, let's just say I wanted to cut out this circle, and I go File, Print, and send it to the laser cutter. The laser cutter doesn't see a circle. Okay, what the laser cutter will see is essentially a huge amount of numbers, and it will follow those, kind of like following a map. So it will see exactly where this point is. It will see, I'll just go back to my selection. It'll know the mass for that point. It'll know what that angle handle is doing. It'll know all of that, and there'll be all these basically bits of data that say move here, move here, move here, until it goes to this point. So what the laser cutter sees is just numbers, and then it follows those numbers. So to cut my circle, it will go from here, and it'll go around that path to there, around that path to there, around that path to there, and cut that out. Okay, if I move that in and change that path, the numbers will change, and it will follow those numbers, and it'll do this perfect cut through here as well. So as you saw before, it's just going to move up and down, left and right, and follow those points. So they're vectors. So that's why it needs vector software, because it's just getting those points in time. A JPEG or a photo, it doesn't have that data. Okay, it's just pixels per inch, whereas this is actual vectors. It also means that I can scale this, like I said before, to any size I want, and it stays the same. So I could send this to my laser cutter and cut out, it looks like a weird smile. I could cut this out at a certain size. So like I said, our laser cutter has a bed size of about 700 by 600. So that's a maximum size I can cut one piece. But if I wanted to take this to our CNC machine, bug Matt about that. I'm sure he'd love to show our CNC machine, which can cut out things, maybe 10 times this size. Well, then I can still use the exact same file. Okay, I can send that file to the CNC machine, and it will scale it up to fit the material it's got. So vectors are really important there. So that's our cutting. Okay, pretty simple. The reason why I gave it a red line is depending on the software that you're using. Okay, it'll want to kind of differentiate. I never said that right at all. It'll want to know the difference between the cut and the engrave. Okay, it wants to have that information, and you do that with colors. Okay, so I'm going to say a red line for this instance is a cut line. So whatever is red, I'm going to cut. And then what I'm going to do is I'm going to use, let's just use some text. I'm sure Robbie's sick of me always using him as my examples. I'll increase that. Okay, and I'm going to put that here. Now that is black, okay, which means it's going to be an engrave. I'm going to say black is my engraving color, okay? And then in your software, you can then choose like a range. So I could choose a range of colors. You don't have to, do what they say. I could have a blue color as well, or is that purple? I'm going to do a little blue box, purple box, and I'll move that over here. Okay. And in your laser cutting software, you can basically set what each color does. So I'm going to say the red cuts, okay, so it'll cut through my material. And I'm going to say both of these colors here both engrave, but they're both going to engrave at different speeds and different power. So I can say the black will engrave at, I don't know, maybe 10% power. So I'll get that nice, kind of that soft engrave there. But I might say that purple/blue box will engrave at maybe 80% power, which means it'll cut into the wood a lot deeper, get a nice dark kind of burn through there as well. So you can almost have a range, like think of it like a wave, right? Like you can almost have a range of depths in your cutting. You probably only really do that for things like if you're trying to do a picture, okay? So if you were actually trying to engrave a picture or an image, by having all the different depths, it'll give you different colors, I guess, in the engrave. So you can actually get a pretty decent photo engraved depending on the the dot size and the colors as well. So that's kind of how that works. Okay, so once you have your design here, all right, it's just a matter of taking it into your laser cutting software, and you'll bring that in, and you'll see this in your laser cutting software, and that's where you'll choose to do things like change the power and the speed and those kind of things to get it exactly how you want. So again, that's not the point of today. I'm not going to show you that. That is the next couple of sessions. Okay, so there's a teaser for you to watch those as well. So that's kind of the fundamentals. Let me get rid of some of this stuff here. And we'll go back to what I'm talking about in terms of, say, designing something. So you don't have to, like I said, design everything that's flat. Okay, you can design things that can get put together pretty simply. So there's a box there. And if we want to make this box, say, slot into another box, we're going to build a cube, you can very easily do that. All right, and I'll spend more time explaining the how I'm doing this a little bit later. So again, don't stress about this. I'm just going to quickly make an example of what I'm talking about here. I'm just going to get this. I'm going to make a couple of copies of those. Just going to put that over there. Snap that there. I'm going to snap that there again. Don't stress. We're going to go over these later. All right, don't worry about it for today. I don't want to spend our time walking around Illustrator now. I'm going to move those over there. Okay, and then I'm just going to get these two shapes, and I'm going to merge those together, and I'm going to merge those together. Okay, I'm just going to put this over here for now, and then over here, I'm just going to create another shape that's the same height as that. I'm using it for my guides. Okay, do that. Excellent. Okay, so now I've made a flat pack. Okay, this is still flat. It's still going to cut out flat. All right, but when I take these two pieces out, I can now have these two pieces here slot perfectly into these two pieces here. Okay, so now we're starting to build something. All right, now there's a lot of things, a lot of considerations, obviously. This is a one-way platform, so I can't get you to answer my questions. I could use chat, but what we have here is if this was, say, 3 mil, 3 mil material, of course, then these tabs here, need to be 3 mil, okay, because that material thickness is going to be 3 millimeters thick, so we want those gaps there to be 3 millimeters thick, so that will slot in there perfectly, okay. At the moment, they're probably 10 mil, I just use a random number. So those kind of things are important, all right. And then that will slot in, and then you have, you're starting to build, essentially, a box or a cube, all right? And that's how we get the students to design their platforms. They will start to build stuff like this. We need to get them to think in 3 dimensions, which can be tricky, okay? So how can you think in 3 dimensions? Because you have this flat area here, but we need to think about how we're going to make all of these slot together to create a cube or to create a platform or to create some kind of element that we want to build a chair. There's so much options out there that can be flat packed. That you can kind of put together. Heck, just go to IKEA, right? Everything's there as well. So we need the students to kind of get their heads around how that works. And that's why we spend a lot more time on Illustrator, which is what we'll do later in the week. I keep playing that, right? So that's kind of how you can start to get things that have a little bit of depth to them, all right? So you can actually start to construct products that way. And that is pretty much summing up really where we're going with laser cutting. Again, any questions, let me know. But we don't need to spend too much time on it because that's the concept of it. That's how laser cutting works. And we'll start to make some stuff pretty soon. So I'll just do a bit of a recap on this one. It's not going to be a super long session today because I think we just want to have an idea of an overview of how laser cutting works. And then in the next couple of sessions, we'll actually see some of this stuff happen. And I might even see if I get my gear in time. I might even see if I can't cut out some stuff in my garage and show you a laser cutter in action and how it actually works when we send our things through. So let me recap really quickly. I might jump across back to our slides here. So laser cutting, obviously, is subtractive manufacturing. We have some material, we've designed something, and we're taking that material away from the top material to make our product. Okay, the laser itself is a focused beam. Okay, it's using a lot like light and electricity and power to kind of reflect off these mirrors, send the beam through, and to cut. The laser cutter itself, okay, can go left and right, up and down, and we have a depth because we have a platform that we can move up and down depending on the thickness of the material. And then, of course, depending on the material, that's the power required to cut through that material. So that is our laser cutter there. And then, of course, we need to then make something for the laser cutter. Okay, we need to design something, which we want to cross over very, very quickly. And to design something, we need to use vector-based software. Okay, we need to use software that creates vectors, that creates those paths. We'll jump back here. Those paths, obviously, those vectors are these points here, which get sent to the laser cutter as data, okay? And then the laser cutter, depending on what we say each path does, the colors, will either cut or engrave, okay? And at certain powers, and it will follow those paths and it will cut those things out, okay? It'll have a filtration system to get rid of the smokes and the gases, and then when we're done, we have our final product, okay? So that's laser cutting. Again, I really like it. I think it's a great platform. It's easy to use. I think it's also easy to understand once you get your head around how a laser works. I think it's a really easy to understand manufacturing process. Okay, I really love the idea of getting flat packed products and then making those into 3 dimensions. I think that requires quite a lot of thought and design, which I'm really keen on seeing students do. Students can do it, I think, which is the main thing as well. Doesn't require 3D modeling software, doesn't require being able to model in 3D. It just requires them to be able to think, what is my design going to look like as a flat pack, and how is that going to kind of slot together? Okay, and I think they're really good kind of thinking and thought processes by students. So that's where I like laser cutting, and of course I also like it because it just works. Once you have your design here, you cut it out, and it will be exactly like you have here, which is also the biggest, I guess, learning point that students have. So I talked really quickly about these tabs. So we'll talk about that with students, the thickness of the material and how it works, and they'll cut this out and they'll have forgotten that, oh, this seemed to be the same thickness of this material, it to be 3 mil. So they've made a mistake, but they'll go back and learn. And again, laser cutting is so fast. It is literally, especially with a Trotec file, print, and it will cut it out. They can go back, a minute later with their new design, cut it out and try it again. Okay, so laser cutting is just, it's really, really, really fast to get results out of it. Do your design, print it out, and it's ready to go and to test. Okay, whereas again, 3D printing, obviously it has its own advantages, but 3D printing is not fast. Okay, you send something to print, maybe 12 hours later, you have a look at it, and you're like, oh, darn, that was wrong. Whereas laser cutting, it's almost instant. Okay, so again, that's why I like it so much, and I think it's super accessible for schools. So that's a quick spiel on laser cutting, an overview of how laser cutting works, and hopefully you'll stick with us for the next couple of sessions. Let me just bring those up as well here. I'm going to bring up your jobs, and I'll explain what the other sessions are going to be that will follow on from this. So this is a real quick overview. Let me just go into here. Okay, let me have a look what's coming up. All right, let me bring this down here. Excellent. So tomorrow is a bit of a design thinking overview. That's a very kind of quick overview of design thinking and how it works. Some of you may have already done that. That's just me going over it again, probably a lot better than I did the first time. But then what we have here for the 28th and the 29th, which is next week, so that gives us time to have a think about this, is I'm going to be looking at 2 pieces of software in depth. Okay, I'm going to be looking at LightBurn, which is the one I would strongly recommend that you look at using for your schools. Okay, there is an educational license, which is great. So that is going to be on the 28th. That's all going to be about how you get and create a design and how you actually get a laser cutter to cut it. Things like cutting depth and speed and laser power and all the really important stuff is going to be in that session there. And I'm also going to then go over similar techniques, but in Illustrator, because that also uses the same kind of techniques as LightBurn, except it's a lot more expensive. So the next 2 days, the 28th and the 29th next week, are the days where I'm actually going to show you how to create something. And what we might do in those sessions is, from maybe a rough sketch I put together, we might actually create, design, and cut an actual product from 0 to done. So those will be those 2 days. So I'll definitely tune in for that one on now the making of things. Now you have a rough idea of the overview and how it works. So thank you so much for your time. I'll double check chat. I think it's all quiet. It generally always is all quiet in chat. I think maybe people are just, too busy listening to my dulcet tones that they don't want to answer any questions. That's okay. So I'm going to sign off from here. What I will do as well, there was a link to book in for this session, and again, please do that. I think you can do it after the fact. It's just good for us in terms of our attendance and knowing who's looking at what. So please fill out those details. Those details will be in the link. It will be in the description below. So click on that, and I'll put a survey link up there as well. I might push the survey out to anyone after our sessions next week, because I think they kind of all roll into those, so that would be a better idea to do it then. But I'm going to end the session now. So thank you very much for watching. Clearly, I do like laser cutting. Thank you very much for watching, and I will hopefully see you in the next video.